people have heard of ROS, the Robot Operating System?
We talked about it last week.
Yeah. That's not fair. Outside of that context. Yeah. Okay. So it started 3 years ago. It was developed at Stanford in the STARE robot program, which is the Stanford Artificial Intelligence Robot. And they call it a open source meta OS. Open source, of course, meaning it's free and you can use it in your projects. And a meta OS because it's sort of a framework or an OS running on top of whatever your normal system operating system is. And there's a picture over there of the PR2. That's developed by Willow Garage. It's an assistive robot. And they're the ones that have sort of taken ownership of ROS and are releasing kind of biannual or annual updates to this general framework that you do the work with.
Really quick, like this, we have a bunch of slides presented, but if you guys want to interject and just ask a ton of questions, like that would almost be ideal. So we can fill the whole time, but this can be like a very open, informal discussion too. So
yeah.
Ask away if you develop questions as we go.
Yeah, and another disclaimer, I started using this in November, Jarvis not soon after, not long after, and so, you know, we're not experts, we have some experience. I think we can give you a general feel of what it can do, but I'm not going to hit all the details. Okay, so what is it in general? Jarvis and I talked about this quite a bit. I think a lot of you can probably relate to the situation where you're working with a complex mechatronic or robotic system, and as you're developing it, you have to create all this structure for yourself, like a communication protocol, and you might be doing that with strings, or maybe you have checksums at the end, and you might have to create your own drivers to interface with chips or other hardware, cameras, for example. Maybe you have to create your own extended Kalman filter or other types of filters, and all that's a lot of work. And when you're done, it's probably going to work really well, and then you're going to finish the project, shelve it, and get your thesis and leave, and no one's ever going to have access to that code again, more or less. So they're trying to address that issue, Willow Garage with ROS, by giving you a framework that makes it easier to do some of those base tasks. And in doing that, you lose a little bit of flexibility, but because you step into this framework, you can now use other people's code. And the community that's developed around ROS is such that when you adopt it and use it, then you make your code available to others. So it's kind of like an organic growth thing that happens. Another feature of it is when you're working in it, your work becomes very modular. They have these things called nodes that you develop. Each sort of task you do is a separate thing that you can start up and shut down as you go, and work on them separately, or people can just take those components and they'll run all by themselves. And another note, which is a little bit harder to explain, but it kind of makes the computer feel more like working on a microcontroller, because you can now say, I want this to run at 30 hertz or 200 hertz, and it does. And so it strips away some of that uncertainty that's there in Windows, where you might say you want something to happen every so often, and the USB drivers just decide that they're going to add some latency or lag to it, and there's nothing you can do about it. So that tends not to happen as much.
So, sorry. So you said that this is a meta-level OS.
Yeah.
So it runs on top of Windows, presumably, as well. Sort of.
It kind of does. Is it just within the past 2 weeks they said, look, we got it running in Windows, but like they have not released anything.
So what does it generally? Does it generally just run on Linux?
Yeah, Linux.
Okay, and when you run it in Linux, does it take over control of timing?
No, they're doing all of it. I mean, your full operating system is running regularly. You could be browsing the internet or something while this is running. That's why they call it like a meta OS. It's like internal.
So how do they get that timing control?
They what's that?
Probably have a device driver. So they
Well,
can work at that low level.
I mean, yeah, I don't think we really know the details.
But
that well.
what we do know is when you ask something to run at a frequency, you can check what frequency it's running at, and it does it.
They use this package called Boost, which is like a multi-thread processing thing, like crazy. So they can, whenever they want, like start new processes and stop processes, and it makes like the real in-depth code of what ROS is doing like unreadable. But it sort of just takes care of that, like stuff that makes working with hardware on a PC hard.
Okay.
In general, it just sort of does it for you. Yeah.
So I know you said you don't. Well, I guess I just ask you. So is it like a? It's not a real-time OS pairing of Linux. It's running. It's just like plain kernel.
Yeah.
Yeah.
It's not a real-time OS.
I tried to tell Jake, in my eyes, it's trying to be a real-time operating system. He was like, you cannot make that claim because someone will disagree with you. So I'm not making that claim. But I sort of have that opinion.
But there is a branch of the Linux kernel that is, well, it says not, that does have real-time components where it does try to make the Linux OS actually real-time.
Yes, absolutely. But what's awesome about this is you can just work in a regular old computer. Like, you can have your computer that you browse the internet with and play video games with could be the exact same computer that's controlling your robot. You don't need, like, special version of the operating system. Right? It's just sort of like a shell that fits inside the operating system.
How did you guys install it?
So they have, it's a repository. It's on apt-get. So they have a walkthrough. It's very detailed for Ubuntu.
Okay.
And there's tons of tutorials, and there's a huge community. We'll talk a little bit more about that. But it's, what would you say, 2 hours, an hour?
Well, so they release updates that are already compiled, like binary versions, in their repository. You can probably install one of those if you have a fast internet connection in 20 minutes.
Okay.
But if you want to build it from source and get like the newest version, it's a few hours of compile time.
Did it use like the patch manual and stuff?
No. Yeah. I don't think we've ever had. Now, it's designed for Ubuntu, which is the Linux distribution. We're using it in Ubuntu, which is really nice. But I would say we've never tried to compile it and had it fail. Like they're pretty good about only releasing stuff that's going to be stable. We've gotten sort of caught in a trap where they've, like in the middle of an upgrade, where they release some new parts but not all new parts, and then you try to compile and you're like, all these errors come up, but then you try it in the morning and it's all better. You know?
So I would say 20 minutes if you've done this many times.
Yeah. Fair enough.
Okay, so it's, I think, like we said, mainly on Ubuntu. They do some testing on Mac OS X, but I do not know how sort of easy that is to get running. Windows, just recently, they said that somebody got it working, and it can run on phones, Android and iPhones, but you'd be kind of on your own. There's like a small community that does that. When you're working in it, you can program in Python or C++. That's like how the languages you interface to ROS with. And this is sort of just a feature that when you read comparisons of ROS to other things like ROS, they say that it's lightweight. It doesn't wrap a loop around your code. It sort of runs things in parallel. And then again, as we noted, not real time.
With that parallel thing that he said, what that means is if you guys already had code running, it's generally very easy to just write a few extra lines to get it into ROS. If you have something that does something that you like, it's not hard to just turn it into a ROS node to get stuff from ROS. It's very easy. You can reuse stuff a lot. Like, even though it's only in Python and C++, if you, say, wrote something in MATLAB, it's not hard to write a ROS node that all it does is receives a command from ROS and then calls your MATLAB code, executes your MATLAB code, and then brings it back and sends it out to the other parts of ROS. And it would literally be like 30-line, 20-line, little tiny function that activates the ROS node. So.
Okay, so here is their description of what ROS is and what it's used for. We're going to try and show a lot of videos, give you their perspective.
ROS is a software development platform that integrates many libraries and tools that anyone working on robotics needs so that they can start working at a higher level when they begin. You start out with libraries for everything from low-level hardware drivers up through navigation and 2D and 3D perception. You also have a full set of developer tools for logging and playback, calibration of the system, and even tools to help share code with people at other labs.
This is RViz, our 3D visualization environment. It's showing us the robot side view. We're seeing where the robot thinks it is, as well as the data from the laser scan. RViz lets people see what the robot thinks is going on as opposed to what is actually going on in the world, which can often be two very different things.
Because all the libraries and development tools are open source, people can use them freely, people can improve on them where they don't meet their needs, and people can develop new capabilities and easily share them with the rest of the community.
One of the things that's really exciting about ROS is it's available to anybody. So even if you're not a part of the beta program, you can still download ROS and develop either on your robot or on simulated robots.
Over a dozen institutions, corporate research labs, and universities have released open source code for ROS.
The open source community around ROS has been amazing, and we're excited to see what happens now with the beta program.
What we've seen is that once people port ROS to the robot, they love the development experience and the tools that it offers them. The capability to do debugging in the real system, the capability to visualize and log the data, the capability to share their code with other people.
Okay, so you saw, we talked a little bit about RViz. We'll touch on that a little more, and maybe at the end we'll give you a demo of it in time. So they mentioned that a bunch of people are jumping on this bandwagon. The nice thing about that for us is that it's kind of accepted that when you use it, you then make your code available. So if someone's working with a particular sensor, now you have access to their drivers that they've developed. And because you're working both in ROS in the same framework, you just take it and you start that node, and it kind of just works. It's crazy. Okay, so we got some pictures here. I don't know if you guys have seen the Minority Report interface that MIT developed with the Kinect. You can see this is from the Kinect's view. It's finding the two hands from the skeleton data, and then it's finding the fingers, and then it's kind of outputting. This is the final output, is the fingertips and the center of the palms. And you can see that I'm finding vectors along the fingers, so you can actually sort of talk to the computer with your hands. That was a pretty cool little demo.
We ran that demo, by the way. Like, once you have ROS going, it's like very short. Just install the MIT package, run, and it just works. Like, and you can then see exactly how they did it, because it's all open, easy to get to.
Yeah. Their code might not always be very well commented, but okay. And then the upper right is the PR2. It's doing some path planning, trying to figure out how to pick something up. And then the lower right is some LiDAR data, and you get a similar output to what the Kinect gives. There's this little humanoid robot, I don't know what it's called, but it's in a lot of these videos. Okay, so here's the nitty-gritty kind of ROS. The main thing that you end up working with in ROS are these packages. There's the things that contain the drivers, the libraries, and the processes that you're going to use. The processes in general, they call nodes. And you're going to write this stuff in C++ or Python. And so all of these nodes that you start up need to communicate, and they're going to communicate in a set way, in some sense. They're going to use messages, and messages are really like as in C, it's a hierarchical structure of arbitrary data types. So you can just say, for example, with the Kinect, we have a skeleton message type that has a component of it for each joint, like shoulder, elbow, and each of those has